Hello everyone, you're welcome to Easy Math with Adibadi, and today we'll be concluding indices. So we are taking indices part 3. Alright, we've gone through all these laws from 1 to 6, and today we'll be looking at 7, 8 and 9. Now, these 7, 8 and 9 are a little bit, maybe, I don't want to say tougher than the other ones, but if you just listen, I will explain it in a very easy way for you, and then we'll be able to go. Now, look at this. You have b raised to power minus x. If you look at this law 7, it's like this law 6. The only difference is this x at this point instead of 1. So the easiest way to remember, and that is how I explain to my students, is that see this negative sign as horizontal line that it is, and then turn it to vertical line and let it be the one that you have here. That is, take this negative and turn it to 1 and put it up here. Whatever you have left, that is b raised to power x, will now be the denominator. With that, you can solve this question at any time. Alright, law 8 says b raised to power x over y. This implies that you should look at the denominator and make it the root of the number, then raise it to the power of the numerator. You see, in some textbooks, or some people prefer to write it this way, which means the same thing: b root of b and all raised to power x. This means absolutely the same thing. Now, if you look at law 9, this is the combination of 7 and 8. Now, the only difference between 8 and 9 is this negative sign. Okay, if you remember what I told you, that when you see it raised to a negative number, what do? We turn the horizontal into vertical, and it becomes the 1 on the numerator, and the every other thing becomes rule 8, and then we apply it under it. So with this, let's go to our examples. Now, number 1, you have 125 raised to power 1 over 3. Using our law over here, this implies that the denominator is 3, so we find the cube root of 125, and then we raise everything to power 1. And what is the cube root of 125? Is equal to 5, and so your answer is equal to 5. Method 2, which I see as easier, is that look at the power that I have. Look at the denominator of the power. The denominator is 3. So I think of a number that I can raise to power 3, because 3 is the denominator of my power. So I write 5 raised to power 3. Can 5 raised to power 3 give me 125? Yes. So it means I have done nothing. So 5 raised to power 3 times 1 over 3. Right? Because you know, when we raise it to power, we multiply, right? When we put a bracket, rather, we multiply. So this will cancel this, and then we have our answer to be 5. When I do more examples for you, you should be able to get that method, okay? Now let's go example 2. What do we do in this case? You find the cube root of 27 and then raise it to power 2. So what's the cube root of 27? That's 27, that's 3. Then we raise it to power 2, and then my final answer equals 9. Now, using the other method, so what will you do? You look at the denominator of your power is 3. So what can I raise 27 to? What number can I raise to power 3 that will give me 27? So if I do 3 raised to power 3, I think that should give me 27. Then I multiply it by 2 over 3. And then I am there. 3 raised to power 2 will give me 9. Example 3. Now this is like taking the reverse of what we know. Now remember, I told you from this rule that when you want to solve this question, the denominator is the root, then the numerator becomes the power that you use to multiply. So if I am to write this, reverse it, it means that this is going to be 5. Since the numerator is the power, so I can write 8, and the denominator is the root I am taking, then it becomes over 2. Brothers and sisters, break it down. 1 here, 4. So this is going to be 5 raised to power 4. So your 5 raised to the power 4 will give you 625. 625 if you wish to write the value out. Example 4. Now, can we just apply the same thing here? We find the cube roots of everything. 6, 4, x, 12. Then we raise everything to power 2. So what is the cube root of 64? 4. Okay? And then cube root of this is x raised to power 4. Then we raise it again to 2. So what is 4 square? That will be 16. And x raised to power 4 times 2 will give us 8. Method 2, which I will be using henceforth. Now, I think of a number. I look at the denominator of the power, which is 3. I think of a number that when I raise it to power 3 will give me 64. And that's going to be 4 raised to power 3 should give me 64. Then, remember when we have a bracket, we multiply. Using this rule, AB raised to power x. So I will use it to multiply that. That will give me times 2 over 3. Then I deal with the x values. So this is x raised to power 12, and I'll still multiply with 2 over 3. I'll multiply with 2 over 3. So 3 here 1, 3 here 4. 3 here 1, 3 here 1. So I have 4 raised to power 2. That will give me 16. X raised to power 4 times 2 will give me 8. Can you see that this is super easy? If you get this, give me a thumbs up. All right. So I write this as 81 raised to power minus 1. I have not done anything. Then I have minus 3 over 4. I can decide to multiply this out. Minus times minus will give me plus. So I have 81 raised to power 3 over 4. Are you wondering where the negative went to? Remember I said minus times minus will give you a plus. Okay, so I look at the denominator is 4. What number can I raise to power 4 to give me 81? And that would be 3. 3 raised to power 4 will give me 81. Then I have 3 over 4. Remember when we have brackets, we multiply. So that means 4 will cancel 4. And then I have 3 raised to power 3. Everybody, what is 3 raised to power 3? That will give us 27. Math is easy. All right, so we go. Example 6, 1 over 4, I rewrite as 4 raised to power minus 1. At this point, you can pause and solve yours before I finish solving mine. Okay, so I can rewrite this 0.5 as 1 over 2 just to make things easy for me. So I can take this negative out. Minus times plus is minus. So I write this as 4 raised to power minus 1 over 2. I have not done anything extra. So this 4, we can rewrite it in such a way that we have something raised to power 2 because there is 2 here at the denominator. So which will now be 2 raised to power 2 into brackets minus 1 over 2. So 2 cancels 2, and then we are left with 2 raised to power minus 1. You can leave your answer as this, or you write it as 1 over 2 or 0.5. The last example, and from henceforth, I believe you'll be able to solve indices. So let's go. So what can I raise to power 3 to get 8? So I can have 2 raised to power 3 will give me 8 here. So I do times 2 over 3, then times, what can I raise to power 2 to get 49? So I have 7 raised to power 2 times minus 1 over 2. Can I break this down? Yes. So this will go here 1, here 1. And this also will go here 1, this will go here 1. So I am left with 2 raised to power 2, which is what? 4 times 7 raised to power minus 1. No, 7 raised to power minus 1. Now, if you look at these two values, you realize that they are not of the same base, so you cannot use law of indices there. You just do the normal arithmetic. 2 raised to power 2 will give you 4 times. So if you look at this 7 raised to power minus 1, it could be written as b raised to power minus 1 equals 1 over b. So I will write this as 1 over 7. And that will give us 4 over 7. That is all about indices. I'm super sure you've learned something. Thanks for your time.